Alright, hi everyone. This video, if you want to find the notes for it afterwards, you can find it in the content library under Sketching Parabolas. Okay, we're going to start off with a quick review of where we've come from. So, you might remember that there's actually three ways we can write parabolas. We can use expanded form, like the following. For instance, you might have x squared minus 2x minus 15, that's an expanded form. You might have factorized form, which we'll come to in a second. You might also have a different parabola in turning point form. Maybe it looks like this, x minus 1 squared minus 16. Now, things will look different, of course, in these forms, and so we'll treat them differently. Let's first think, what happens if you get it in expanded form like you have on the left? Well, if you get an equation like that, you're smart to always find the y-intercept first. And the y-intercept is really easy because you make x 0, meaning you get 0 squared minus 2 times 0, take away 15, which of course equals 15. So the y-intercept in coordinate form is 0, 15. Now, in other words, if it's an expanded form, minus 15, I should say, the y-intercept is always just this term at the end. Now, the second thing you should do if you're in expanded form then is, of course, you need to find the x-intercepts. So to find the x-intercepts, what you've really got to do is write it in factorized form. So you want to start off by factorizing, and here it's a quadratic trinomial. So you use the trinomial factorizing, giving us an x. Thinking about this bit here, we need two numbers that multiply to minus 15, add to minus 2. So that's going to be a minus 5 and a plus 3. Once you've got that, you remember that x-intercepts happen when y is 0, so you've got this x minus 5 times x plus 3 has to equal 0 because that y is 0, and therefore using the null factor law you have x equals 5 or x equals minus 3, and writing those as coordinates, that's a minus 3, writing those as coordinates 0, 5 and 0, minus 3. So that's the key stuff, of course, and once you've got all of that, you can start doing your sketch. So here's the sketch, y-axis, x-axis, passes through these two x-intercepts. Here we go. So here we've got, I've written these backwards, off to a bad start. 5, 0 and minus 3, 0, much better. Sorry about that. So we've got minus 3, 0, we've got 5, 0, and that y-intercept that we found a second ago, scroll up if you want to find that, is 0, minus 15. We also, of course, need to find the turning point. Now, you might remember the turning point is exactly halfway, my sketch is not perfect, but it's exactly halfway between the x-intercepts here. Whoops, that's not done properly. Exactly halfway between the x-intercepts. So to find it, we take the average of the x-intercepts. So to find the turning point, the average of the x-intercepts, so that's minus 3 plus 5 divided by 2, that's finding the average. And that gives us 2 over 2, which equals 1. So that's the x-coordinate, and now we need to find the y-coordinate, and we find that by subbing it into the original equation. You might remember the original equation was x squared minus 2x minus 15. So we put 1 in for our x value, giving us 1 squared minus 2 times 1 minus 15, which is 1 take 2 minus 15, which is minus 16. So that turning point, therefore, the turning point, we can jot that down, is 1 minus 16. So let's add that into our graph. 1 minus 16. And just to confirm that it makes sense, is minus 16 lower than minus 15? Yes, it is, so it all makes sense. So, to conclude, we have here expanded form. Expanded form is good for the y-intercept. The first step we'll need to do is factorize it to then also find the x-intercepts. Once we've got the y-intercept and the x-intercepts, we can do our sketch. Finally, we need to find our turning point. The turning point's halfway between the x-intercept, so we take the average. Then we need the y-coordinate, so sub it back in, find our turning point down here, and you can put that onto the graph. Okay, that's quite distinct from the method that you would use if your equation is presented to you over here on the right-hand side in what we refer to as turning point form. Now, turning point form, we use quite a different procedure. You might remember that, let's just do it in general. In general, turning point form looks like this. X plus, let's do a minus here, sorry, x minus k squared plus h. Okay, that has a turning point at kh. In other words, because there's a minus sign here, because it's a minus k, that strangely takes it into the positive direction, k units. And because we've got a plus h, that takes this whole graph up h units from the original graph. You might also remember that a just determines if it's upside down and how wide it might be. So that's what we do in general. So for this specific case over here, you can tell straight away that because it's got a minus 1, it's gone this way 1 unit and it's gone down 16 units. So that means that we have a turning point is at 1 minus 16. So that's not all we need though, because of course for any graph we need more than the turning point. We need the y-intercept and the x-intercepts. So y-intercept, of course, is found always the same. We just make x 0. So here we put in 0 for x. Okay, that just becomes a minus 1 squared. Minus 1 times minus 1 is positive 1. So we get minus 15 for the y-intercept, which we can write, of course, as 0 minus 15. So that's the y-intercept. Next, we'll find the x-intercepts. As you know, the x-intercepts occur when y is 0. So we've got the x minus 1 squared minus 16, which equals 0. First step, we add 16 to both sides. The next step is that we square root both sides. And here you might remember from quadratic equations, something interesting happens when you take the square root, which is 4, and that is you need to remember it could be plus 4 or minus 4. Because if you do plus 4 squared, you get 16, and if you do minus 4 squared, you also get 16. So it could be either plus 4 or minus 4. You could write it like that, how I've written it, with the plus minus symbol, or if you prefer, you could also just write minus 4 and use a word or plus 4. It doesn't really matter how you do it. There's a final step, and that is to add 1 to both sides. Now, if what you're dealing with is a plus 4 and you add 1, you get 5. But if what you're dealing with was minus 4, if you add 1, you actually get minus 3. Okay, because you could add 1 to either 4 or minus 4. So therefore, we have result x-intercepts of 5, 0 or minus 3, 0. So we've got our key values now. We've got our turning point up here. We've got our y-intercept. We've got our x-intercepts. And so we can now sketch our graph with all of that information on it, which will look a bit like this, x, y. Here comes the graph. So that's 5, 0, minus 3, 0. Y-intercept is minus 15. And the turning point, the thing that we found first, was 1 minus 16, which was just up here, 1 minus 16. There it is. So, did you notice, by the way, that this graph actually is exactly the same as the other one? Take a look at all those points. They're the same. But the approach, the procedure was different. If we're dealing with expanded form on the left, what we did was first find the x and y intercepts. Then, afterwards, we found the turning point by finding the middle of the x-intercepts. On the right-hand side, we're in turning point form, so we found the turning point first, and then we find the x and y intercepts afterwards. Now, these equations obviously produce the same graph, so there must in fact be the same equation. Let me just write both of these again down the bottom here where we've got some space. We had x squared minus 2x minus 15, and the other one that we had was y equals x minus 1 squared minus 16. And these they must equal each other. So how can we prove that they equal each other if we wanted to? Well, we could start with this one over in turning point form, and we could expand the brackets, because x minus 1 squared is the same as x minus 1 times x minus 1. And then we can do this thing where we do x times x is x squared, x times minus 1 is minus x, minus 1 times x is minus x, minus 1 times minus 1 is plus 1, take away 16. Okay, and you see what we end up with is actually what we had over on the left-hand side in expanded form. So you can see that they're actually the same. They're the same equation. So, nevertheless, even though they're the same equation, the way that you would actually sketch the graph, the procedure you go through is actually a little bit different, as you just saw. Okay. Next off, I'm going to do just two more examples, one more example for each type, but this time the graphs may in fact be different. So let's start off here with a fresh graph. This one we'll do is the following, minus x squared plus 6x. Now this one is in fact in expanded form. There's no brackets, it's not factorized, and it's not in turning point form either. So, what do? Well, first we find the y-intercept. We sub 0 in for x. So here we get minus 0 squared plus 6 times 0, and you can tell that that is 0. So the y-intercept is 0, 0. Next, we find the x-intercepts. Now, to find x-intercepts, we factorize the equation. Now, here, the most important thing is realizing there's a negative sign. So we have to factorize out that negative sign first. So first we'll factor out the minus sign, giving us x squared minus 6x, because we factorize out the minus sign from both bits. And now we can, this one's actually a common factor. It's not a monic trinomial anymore. So we'll take out the factor of x next, and that'll leave us with an x minus 6. So you can see that once we're factorized, you can see that we have x-intercepts. Because this has to equal 0, we must have x-intercepts at 0 or at 6. Therefore, the x-intercepts is 0, 0 or 6, 0. Okay, so we've got the y-intercept, we've got the x-intercepts, so we're now ready to kind of sketch the shape of the graph. Must go through all those points we've just mentioned, so it must go through the origin, 0, 0. And it must go through this point 6, 0. Now, key thing, remember this negative symbol at the front here means that instead of the usual look to this thing, it's not like that, it's in fact been reflected upside down. So that's very important to remember, that negative sign at the front has reflected the graph upside down, like so. Next, we need to find the middle here, because that'll tell us the turning point. This one you don't even really need to do an average calculation because it's just so obvious what the middle between 0 and 6 is. And that middle, of course, is 3. So the x-coordinate must be 3. And therefore, for the y-coordinate of the turning point, we need to sub 3 back into the original equation, which was a minus x squared plus 6x equation. And so we need to do minus 3 squared plus 6 times 3. So let's do that. It gives us a minus 9 plus 18, which gives us positive 9. So the y-coordinate is 9, x-coordinate was 3. So the turning point, putting them together, we must have had a turning point at 3, 9. Back on the graph here, 3, 9. There we go. And there is a perfect graph of our parabola there. Alright, one final example for us today. That one looks like this. Okay, well here you notice that it is a turning point form graph. You also notice the 2 out the front means that actually this graph is skinnier than an original parabola graph. So it's in turning point form. The first thing we'll therefore note down is what the turning point is. And the turning point plus 3 actually, remember, makes it go in the negative 3 direction, and minus 18 makes it go down 18. So what we're dealing with here is a turning point that's at minus 3 minus 18. Next, let's find the y-intercept. Now the y-intercept, of course, occurs when x is 0. So we have 2 times 0 plus 3 squared minus 18. 0 plus 3 is just 3, so that's 2 times 3 squared is 9, take away 18. 2 9s is 18, take away 18, gives us 0. So we have a y-intercept at 0, 0. Okay, next, of course, perhaps the hardest part of this is to find the x-intercepts. Now the x-intercepts happen when y is 0, so we have the equation 2 times x plus 3 squared minus 18 equals 0. First we'll add 18 to both sides. Now we'll divide both sides by 2, giving us 9. Next we've got to take the square root, but when we take the square root of 9 is 3, but we have to remember it could be the positive or minus 3. Last thing is to take away 3. So if we had a plus 3 and we took away 3, we'd get 0. And if we had minus 3 and took away another 3, we'd have minus 6. So for this particular one, we have x-intercepts at 0, 0, and the other one is at minus 6, 0. There's no negative sign at the front of this graph, so this is the regular parabola like this. And you can see the key points we're going to be putting on is the turning point, minus 3, minus 18, the y-intercept of 0, 0, and the x-intercepts here, 0, 0, and minus 3. So let's put all of that information onto a set of axes here. So we've got an x-intercept at minus 6, 0, another one here at the origin, looks a bit like this, and the turning points, do you remember from the top here, minus 3, minus 18. Okay, and there is our nice parabola there. Okay, well, hopefully what you've learnt is the difference between your approaches to sketching depending on what the equation looks like. Like this last one, was it in turning point form? Or, like the previous one, was it in expanded form and therefore needing to be factorized? Hopefully you've learned something. Remember, email if you have any troubles or ask me in our live lessons. Otherwise, good luck. Remember, the next thing to do is to get into the mixed sketching task. That is your task for today. See you in class.